Hey, welcome to the Linux channel. So yesterday and day before yesterday I was having some teaching session, and I was teaching a couple of students, and I was teaching about process and process synchronization and synchronization within threads and stuff like that. So which is when I thought let me shoot this video episode, because there is a lot of confusion which exists among anyone who starts systems programming, because the way the things are taught in their colleges, and then they tend to sort of, even more further after they finish their graduation, they, go through all these things just for the sake of getting a job, and in terms of answering their interview questions and stuff like that. But unfortunately it is not their mistake, it is the stupid education system we have, especially in India, because if you take, for instance, schools, they kind of tend to force students to by heart things, and they tend to make them write whatever they remember by doing by hearting. Essentially they don't teach anything so that they understand the things conceptually, and then they can put back their thoughts in terms of examining their skills. But this doesn't happen in India. It's the same thing happens in the college, and you have mostly the staff in the college, they never have done anything in the real world, so they take some books and then they teach as per the syllabus, and with that it is all done. So this is a huge confusion which exists. I am not talking about just one student which I have dealt, or couple of students which I dealt. I have seen this time and time again. They have huge confusion, and also there is also another confusion. Let's take for instance IPC, or let's take for instance synchronization or something. They tend to understand, or they tend to learn everything as a part of their know-how or skills, or development of skills. But to be frank, I'm telling you, like I mentioned in few video episodes, there's a question of you have 5 varieties to do something, but it all depends on your architecture. If you ask any architect, he may use just 1 or 2 techniques time and time again, due to that overall advantages and also the business aspects and stuff like that. But there are also other aspects which may exist, but at the same time may not be required in all the cases. So this is also there. So as a student, if you are watching this video, it is good to know several things, but again it is also makes sense. You have to go through some real code, not some project done by your seniors or something. Okay, real any code. Take for instance any open source code and examine it, and try to understand how they have architected. I have done many code walk sessions. You can do that in a similar way. It is still difficult, I can understand, for a fresher, but or a college student, but you can do that as such. So let's come back to this topic, and we discuss something about synchronization in a process thread and stuff like that, because this is something very much people are confused about. So when you architect something, you have some choices. You can do multi-processing, and I'm not mean to say that you have to create that fork and child process, all this bullshit. I'm generally saying you can create multiple processes with multiple daemons. So you have some choices like that. And you have also a choice where you can create multiple threads in a single process. So you have that balance between, suppose you need some 60 to 100 processes, you can do that, or else you can do 50 processes with each process 2 threads, and then you can have 100 instances. So this is something extensive I have discussed in a very old video. You can go through somewhere here, or you can search in Linux channel website, process versus threads. I have done it long back, somewhere here. You can just remove this language option. Yeah, in this section of videos, you can see here it is a part of systems architecture. So in this I have discussed about this particular video. This is for a systems architect Okay, this is not for beginners or students. Having said that, you can just have a look of this video. You may understand to an extent. To an extent, it is not for anything which you can take readily, because this is really meant for some advanced architect, somebody who is in the industry for some time. So I was telling various examples like a Xeon processor, how it impacts the amount of CPU cache you have, how it impacts in case if some process crashes and stuff like that. So I suggest you to watch in relationship to this video. If you are a beginner, you may not understand fully, it is still fine. You can watch and then you can get some idea about the same. So this is not for beginners, so you can watch the same. The second video I have done also about how it loads a CPU core whenever you invoke any threads, multiple threads like Pthreads in Linux system. So whenever you create a Pthread instances, how it latches to the CPU load core, and then how it impacts the performance and stuff like that, how it actually consumes the hardware resource. So that's what I have discussed in this video. So in relationship to this video, I suggest you to watch these two videos. What I can do is this particular video, once I edit and publish, I may publish in the tutorial section. In the tutorial section, I am going to add all these links so that you can go and watch the same to get that entire big picture. So I can give one single link to that tutorial page in this video description. So this makes everything easy. So let's come back to the topic. So apart from these two video episodes, again, this is something I have discussed about Pthread synchronization via Mutex, and also I have discussed about the shared memory as one of the IPCs. Because shared memory is quite tricky, it is not like POSIX. So message queues and sockets is like a messaging system including the socket. So let's assume you have some sort of an envelope like this. So you send from one location to the other location, same thing happens. You can send it from one process to other process, or one thread to the other thread also. So something like that, you can do that in this platform. Versus shared memory is quite different. Shared memory, as the name says, you have a shared memory between multiple processes. So this is not required. You have multiple threads within the same process, because each thread is going to share the same memory space. If you are very new to that, of course you need to read the entire fundamentals. So if you have multiple threads and if you have some global variable, all these threads can share. So as simple as that. So I have come up with a few slides and I can just walk through so that we get some good picture. So I come with these series of slides which can illustrate this entire aspect. So apart from those two videos about process and threads, it's not really a comparison between what is a process versus a thread. Please understand, don't confuse with the title also which I have put. It's not that I'm discussing about what is a process versus what is a thread. It's a video title about something about architecting the system. The second one is something completely different, how the threads will latch on to the CPU, how it consumes the resources, hardware resources, versus how a process will latch on to a CPU and consumes the hardware resources. That's the video is all about. So coming back to this, this is the first slide. I have done some few slides, as you can see here. So we go back to this first slide. In this first slide, we can take a scenario. We have one process. In that process, you have a global variable. It can be some buffer, it can be anything, it can be a global resource. So you have a global resource which is a shared resource. In that case, what it means, a shared resource is in this thread, in this thread, in this thread, all these threads, you are trying to use that shared resource. Let's assume you are trying to write and read something you are doing in all these threads. So whenever you do that in all that execution context, then you need some synchronization. You need a synchronization between these threads. So this is one scenario, you need synchronization. So once again, if I get back to my intro, I said the way they teach you is completely wrong. The way they teach you is they tend to make some point that somebody have to learn synchronization and somebody have to learn whenever you do multi-threading, multi-process or something, you have to know synchronization, all this bullshit. This is all, it's a kind of a vague idea. It's been put forward. It all depends. Whenever you do synchronization, it's the most dumbest way to kill your performance of your system, because the idea of multi-threading and multi-processing itself is to use your resources as much as possible, do parallelization, do load sharing and stuff like that. So when you do load sharing, whenever you do synchronization, it kills the performance, as simple as that, because you need to wait till one execution context, whether it is thread or process, completes. The other execution context have to wait, so it kills the performance. So come out of all this bullshit learning curve, whatever you had earlier. So I am a systems architect who works in the industry. I am telling you, synchronization is required only when it is needed, like this case. Okay, you have a shared resource and all of them are using the same shared resource as it. So if you see the other slide, this is a small variant. In this slide you have that global variable. This is what in the textbooks they almost always mention as a shared resource, that's what. So in this example you have that global variable, but the global variable is not used in these threads. So in this example, since they are not using that shared resource, those threads are not using any shared resource within the same process, you don't need any synchronization within these threads. So as simple as that. So in this context, you don't need any synchronization because it is not using any shared resource, although it is a multi-threaded application. So let's move on to the next slide. You have another scenario where you have multiple processes and all these processes are using a shared resource like this shared memory, because it's a different process, each have its own memory space. Okay, each have its own memory space. So whenever you have like this global variable like this buff, char buff, it doesn't matter, although each process have char buff within itself as a global variable, each itself is a different process, so there is no point of clashing between them. So if you use that global variable buff, then it is fine. But if you have a shared memory like this, okay, which is one of the IPC mechanism, which is why I said if you use sockets or message queues, it is like a packet delivery system. You are passing some message from here to here and it is nothing shared. But if you use a shared memory, then the confusion starts, because as the name says, it's a shared memory space. So if you do something like shared memory in the form of IPC, because shared memory is one among the IPC methods. So if you do a shared memory, you can see here there are 3 processes using this same shared memory. In that case, the confusion starts once again, because you have this shared memory. Assume this process is trying to write and this process is trying to write and this process is trying to read. Then again that clash happens, and then you need some synchronization between these processes, so that when one process is writing that shared memory, the other process should wait. It can read, but better to wait, and once the writing is over, the other processes can read it. So this happens commonly in a database engines. So that's why whenever you read about database architecture, they mention about concurrency, various other stuff. As a student in the college, you will never understand, no matter how much you study in those books, because all it is conceptually told. It's all useless theories actually. So this is something you will come to know when you do the real code, and this is something partially I have discussed in this video itself, in the shared memory IPC itself. So don't learn all this IPC mechanism, all these techniques just like some Kama Sutra positions. End of the day, in your life you may use some 3-4 position when you have sex. It's not that all the 60 positions you may use. So same thing when you architect something, because this is something I tell to my students. So this is something, when you architect a code or when you architect a software, you have to choose what it suits for that requirement, and also what you prefer for other overall advantages. Sometimes I prefer, for business reasons, for me coding comes next, first comes the business aspect, so I choose something for a business aspect, which is something not many can understand. So this is what it is. So you have to choose what is that it requires, that architecture requires, and based on that you have to choose whichever you need. So that way you see these three processors are using the shared memory, and since they are using the shared memory space concurrent, then you need some synchronization technique. So I don't want to get into synchronization techniques. So you have mutex, semaphore, all that. Let's not get into synchronization techniques. Okay, as a beginner, leave about the synchronization techniques. First of all, you need a synchronization or not is my question is. That's why I thought let me cover this video and clear your clutter in your mind. So the third scenario is you have a single process. In the single process you have 3 threads, and again these 3 threads are using this shared memory. Please understand this is not required, it is optional, because instead of doing this shared memory you can of course do this way, like my first slide. Instead of overcomplicating with an IPC and then again everything using within the same process, you can actually do this in this case. But let's take example like a scenario. So in this case, once again 3 threads are using this shared memory. So each thread itself is a different execution context and it runs parallel. So since it runs parallel, you have to use once again some kind of synchronization technique in this scenario as well, because 3 threads are using the shared memory. Although it is not a global memory, even it is a global memory, you should use synchronization, because it is in the same address space, but it is getting used in a different execution context like threads. So in this case also you should use shared memory, because it is getting accessed by 3 execution contexts simultaneously. So the next scenario is you have 3 processes, and within each process you have 2 threads. So totally there are 6 execution contexts, because you have 2 threads within these 3 processes. So in this case, once again, let's assume each of this thread is trying to access the shared memory, or one of the thread is trying to access shared memory, and all these 3 processes are doing it, latching on to that, resource. In that case, once again you need some synchronization. So this is also similar to this. So in this case also you need some synchronization. In this case it is both multi-threaded as well as multi-process and stuff like that. So again, that's the reason I'm saying forget about which synchronization you need to use. This is the reason in the college books they highlight about synchronization techniques, and they list some 5 techniques, and then they teach you all 5 techniques or something, and then they ask your exam that why a semaphore is used, why some mutex is used, mutex versus semaphore. Again same crap they ask in the interviews. Forget about which technique you need to use. First of all, you need to ask your question, why do you need a synchronization, and what type of synchronization you need to choose based on this kind of complication. So this is the reason I'm thinking to clear your confusion once for all. Okay. So as a beginner, as a fresher, or as a student, you may think it is quite complicated or something, but in a real world situation it is quite common. Things like this will do exist. You can take example like a load sharing mechanism or something like that. For instance, if you take my toffee itself, it consists of several processes and bunch of threads within each process. So earlier it had even 30 threads or 60 threads, or I mean to say execution context, but now I don't do that. It is less than that. So in some specific daemons or processes it has around 5 to 6 execution contexts. So it is like that. So in a real world situation all these things are very common. So You can think this is like a load sharing mechanism. Instead of having one instance, you have 3 instances doing it simultaneously. This is again extensively some examples I have given and discussed with my student last night about some sort of file compression and doing some engine architecture, how these things are extrapolated on a real usage scenario. So I don't want to go much into, because again it is a complete different discussion altogether. So in this case, again you need some synchronization, because you have that shared resource used by multiple execution contexts. So I'm using this execution context in a vague way, so that let's not use the word process also, let's not use the word thread also, because both of them doesn't matter whether it is a process or a thread, it doesn't matter. It's end of the day, it's a execution context. So next, if you go here, this is where, as I said, use your common sense. First, synchronization is required or not. If you ask me, 80 to 99% I never used any synchronization context. I have used in traffic squeezer in kernel space alone. I used spin locks because I'm using I'm an idiot actually. So I used a shared resource in traffic squeezer long back, and using spin locks I was doing some synchronization, and after some time I started removing all that code and I have changed the architecture, and I have used extensively individual buffers for each execution context, parallel execution context. So with that I have eliminated using that spin locks, and also it bumped up the performance. Always you should understand, you should able to shell out more RAM whenever you want performance, and if you try to conserve RAM, then you need to lose the then you need to sacrifice the CPU performance. Same thing is over here. So you have 2 threads, both threads don't have any shared resource, both threads are running. So this arrow denotes its execution context, its flow of execution. So in this context, both are individual, they don't have any connection, no shared resource, nothing. So in this context, you don't need any synchronization. Whereas in this case, it is using some shared resource. So since it is using a shared resource, when this thread is booted up and then this thread is running, and then once it is ready to use the shared resource, it has to wait, and then it is using the shared resource. Once it is used, it is running its execution context. Till that time, using the locks, it is just waiting over here. So you can understand, instead of doing some lousy code like this without no threads also, you can do that. So that is the reason I am saying you, it is so idiotic to use any locks in your code, because it kills the performance. You see here it is waiting, here it is waiting, and waiting means it's not doing anything, it's just waiting for the other thing to complete. So again, here it is waiting, here it is waiting, here it is waiting. So this is what it is. So in this way, synchronization is a sort of a performance killer. So you should be dumb enough to use a synchronization technique simply for the sake of using it. So you need to have an architecture to facilitate in a way that avoids synchronization as much as possible, and use it only when it is required. And when it is required, of course you need to choose some technique and you need to use that's fine. But what I'm saying is, as an architect, if you ask me, because I'm not your average lecturer or teacher, so if you ask me, don't use any stupid synchronization at all. That's the rule number 1. Rule number 2, in case if it is unavoidable, you have some shared resource, you are so dumb in architecting something which may need some more extra memory, but you chose not to use the memory, then you need to get into synchronization, and then you need to sacrifice your CPU performance. So this is something, still as a beginner, you may never understand what I am saying. As you do your real code, as you architect, as you get around 5 to 6 years of industry experience, then you will understand exactly what I'm hinting onto, because you will see more and more code, and you will see also some loopholes, how you can avoid doing such a thing. Without that, you can do something change the architecture and you can try to avoid altogether synchronization itself. So this is what. So I don't want to give more examples, it will again confuse you. Video is not any interactive sessions. I was discussing with my student, I can give some interactive session and I can make him understand step by step, and it's a to and fro communication. He was in some place, I was in Bangalore. I had the same session yesterday with my abroad student also. I can interactively communicate and then make understand what I'm saying. So something like that I can't do in a video, because I just have to say, and I don't know what extent you can understand while watching this video. So that is why I can't give further any real examples. But in a way, in a superficial way, I'm saying, as an architect, I'm saying, if you architect wisely, you can avoid synchronization. Synchronization is a performance killer, please understand. So as a case study, we take this Pthread synchronization and as well as shared memory IPC code. So we can go to the website, tutorials, we take both the code, both the video episode code, shared memory IPC and as well as synchronization. Okay, before taking this, we can take the synchronization code. As you can see, I have attached the link. Okay, and you have this sync via Mutex, because I have discussed without Mutex what will happen, without synchronization what will happen, with synchronization what will happen. So you can see here it has this global variable, like I mentioned in the slide. Okay, like I mentioned in the slide, you have this global variable, but all the multiple threads are trying to access. In this example, I have mentioned only through 2 threads in the code. So you can see here, you have this thread function, and each thread function is trying to access that shared memory resource. So when it does, don't confuse, although it's a global variable, it is using at multiple execution context, which is the reason I'm saying it's a shared memory resource. This is not to be confused with shared memory of IPC. So it is trying to access, so we are putting these logs and we are trying to synchronize it. Okay, so when you try to synchronize, what will happen is whenever one thread is trying to use that resource, the other thread will wait. Whenever other thread uses the resources, this thread will wait. So in a way it gets synchronized, but in a way it is also a bad design. As I say, try to avoid synchronization, because by putting these logs, you are trying to hamper the execution flow itself. So there is no point of using multi-threading. Instead, you can try avoiding multi-threading completely and try to do everything in one thread. So don't do multi-threading and synchronization unless it is really required. Okay, so that is what is happening in this scenario. Very simple. And we take another example like shared memory. So in this situation, I'm not using any locks, because I'm not written a code which is doing an access both simultaneously. So if you go here, let me just open this. So I have given 2 examples. One is a writer. Here you can see here it's a shared memory resource. This buff is a shared memory. So you can see here SHM attach. So we are doing a shared memory attach instead of a malloc. So it is a shared memory. So here in this process, okay, in this code SHM writer, or in this process, we are only doing a memset. Okay, in this process we are only doing a read operation. Okay, so that is what we are not doing a simultaneous write and other type of access. So this is not going to create any confusion. This is the reason I'm not using any synchronization in this example. So although it is a multi-process using a shared memory resource, so in this example I'm not using any synchronization. But having said that, this again will create any confusion. So whenever you use shared memory, maybe most of the times you may need some kind of synchronization to avoid any inconsistencies, because although you read in one process and write in another process, it may get some kind of inconsistent issues, because when you are writing in that and when you are trying to read, it may be writing slowly, and by the time you read, it may take some value before it is written or something like that. So it is advisable in this kind of a scenario, but again, it is not something applicable in all the cases. So again, you need to check whether it is really required or not. Okay. So most of the times it is required for this scenario, because I'm doing a memset here or some kind of memory access and writing it. Okay, whereas here I'm doing a read. So you can see here this for loop, it is reading each byte and then it is printing on the screen. So things like that. So it's an architectural decision. So that's what. So as a case study, you can refer this video episodes as well as those other video episodes about process and threads. In that, one among them is not for beginners, it is really meant for architects. Beginners can watch it, but I'm not sure how far you can understand, because it is not still meant for you. It is really someone who is in the industry for some time and who is done already some software design and already have done that, and it is good to get some level of knowledge to get into that next level, as and when they handle a much bigger and complex projects and it needs some kind of architectural decisions to be taken to accomplish something very specific to that project requirement. So that's all. So often sometimes the shared memory also can be some sort of dictionary or some sometimes you may do encryption or compression, you need some temporary buffer. Okay, and sometimes the libraries, compression libraries, take for instance, I do use LZO and stuff like that. LZO library need a compression buffer, a temporary buffer you need to create before using the APIs. So when you use the temporary buffer, they create only one instance and then they have multiple threads. So for all these threads to use that temporary buffer, if you have only one instance, what happens is you need to use some synchronization like this, and this kills the performance. Okay, if it kills, it is, you can understand from this picture only. When this is running, this is not running. When this is running, this is not running. Then why you need multi-threading first of all, right? So it is killing the performance. So this is the reason when you architect, you can create multiple copies of that temporary buffer and use an individual copy for each execution instance. So that way you can make this code to run something like this. Just use your brain. See this slide versus this slide. This slide is running independent, one thread, and the other thread also running independent without waiting for anything. Versus here it is waiting. So this is like you have a shared public toilet where if someone is occupied, others have to wait outside. So that is this logic. Just imagine, is that is good, or having a toilet for each individual person is better? So although it is not possible, I am just giving an example. So please understand, never use synchronization unless until it is highly required. Choosing which type of synchronization comes next. First thing is, as an architect, you need to first understand whether you need to use for that scenario, spend lot of your time to architecting, towards architecting in a way that to avoid synchronization. Even in kernel space, even in user space, if you have memory is not a constraint, use a buffer, individual buffers for each execution context. That's fine. Okay, you may need extra few kbs of memory or few mbs of memory. Memory is always cheap. Okay, this is something always I tell, you have purchased a system and then I have purchased this laptop, I can upgrade its RAM. I can open the cover and I can upgrade its RAM. RAM upgrade is very cheap. I can't do a CPU upgrade, and moreover CPU is soldered onto this motherboard. I have checked also. So you can't upgrade its CPU. You need CPU upgradation, then take this laptop, throw away and buy a new laptop. That's the only option we have. So you can't upgrade a CPU. Okay. So CPU is a very expensive resource also. When you buy a new computer, CPU is very expensive versus something like RAM. So RAM is also modular, you can upgrade anytime, but CPU you can't upgrade anytime. So this is the business aspect. Again, this is something whenever you watch my videos, many students or beginners may find tough time to understand, because little bit I cover a bit for advanced users. So as a beginner, I am telling you, it all depends on how you architect. It all depends on what is the business aspect. So sometimes it is okay to upgrade your RAM, and moreover your few MBs and few KBs doesn't matter, because these days RAM is very cheap and you have excess amount of RAM. It again depends how you architect based on the available resources, but 90% of the times RAM is not a constraint, which means memory space is not a constraint. So get away with your dumb assumptions of memory optimization. So I have also seen many organizations many MNCs whenever they conduct any interviews, you should understand there is one pitfall in this. The person who conducts interview, the company always gives this task to a person who don't have any projects. Okay, either he is in bench or he is an underperformer. This is the unfortunate truth. You take any top MNC, I can bet you the person who takes the interview is little bit dumb actually. So unfortunately, due to this reason, he asks some FAQ questions. He is good in taking interviews because time and time again, every day he will be doing that work only. So he'll take some dumb example and he will cross question all sorts of scenarios, and if you give an answer, based on your answer again he will ask some other question, and he have a mediocre knowledge. That's the underlying truth. Take for instance any big MNC, I don't want to name it, any big MNC, initial few rounds, whoever interviews you, the person will be dumb. 90% he will be dumb. He may not have any projects, and the company also don't know what to do with him. So most of the times HR will give this job to him so that he conducts first few rounds of interviews and screen the candidates. This is so unfortunate, because whenever I have attended such interviews, whenever I gave this big perspective answers, they can't able to understand. Okay, I always tell this, I'm not a person who likes synchronization. Unless it is required, I don't touch it. That's my only answer. So he may not like my answer. So this is also there. So this is the unfortunate thing about. So as you progress some rounds of interviews, the final few rounds will be done by core developers who are in that project, and even a manager who is in that project. And that is an advantage. They will appreciate your knowledge in case you are knowledgeable. So if you are not, if you are coming from some college based logic and then you have by-hearted something, the person who interviews you is also a medium to below average guy who is going to ask you few FAQ interview questions and going to confuse you and trying to see that whether you are telling true or false or something, you are bluffing or something. His work is to do psychological analysis, and the person who is doing that, most of the times he himself don't have any work other than doing interviews day in day out. Actually weekends they will ask him to come to screen the candidates. Weekdays also he will do till 12 o'clock or post lunch or something. Most of the times first 2 to 3 rounds, technical person, if he screens, trust me, he don't have any real work. That's all I can say. Because if he have real work, he will not have time to sit and do interviews in the first case. So I have been also a CEO. I am telling you, this is what happens in many companies. It is so unfortunate they ask these mediocre questions. But leave all this interview and screening and job. If you are already working in a company, take the suggestion from an architect. Okay, try to avoid synchronization as much as possible, and in case if you are architecting some code or software design, try to find a way to avoid the synchronization altogether, because it kills the performance. Use more memory or RAM, whatever you use the word. I like the word RAM, so use more RAM. It is still fine. It is not going to affect your system. CPU is a scarce resource. Use CPU cautiously and give some justice when you do multi-threading, multiprocessor. You should not hamper its performance by putting all these locks. Okay, whenever you put the locks, it will wait. Each time it is restricted. It will wait again. It will just execute again. It will wait. It will hold. So don't put any holds in such execution context. The more you do that code like that, the more smoother it runs, and it will give you that superior performance. So with this, I would like to conclude this video. hope you guys loved watching the same. If you have anything to discuss, or in case if you are interested joining the classes, be in touch via mail. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.